Alright, so now looking at number 7, there's a couple different ways that we talked about in class on how to solve 7a there. The most efficient way of solving a here is noticing that it's possible to write 125 to have a base of 5. So we could write 5 raised to the x plus 6 on this side, and we can write this, the right side is 5 cubed instead of 125. So with 5 cubed raised to the x power, we really have 5 to the 3x power because we need to multiply those together. So now what do we need to do? Since we have the bases being the same, what that tells us that these powers here have to be the same, so we just solved that problem. So then x plus 6 has to be equal to 3x. Get the x's on the same side. And notice on your quizzes some of you are making mistakes here at this point. Don't overthink this. We just got to get the x's on the same side, which gives us 6 over here, and that's 2x. And then we just got to divide by 2. So then x would be equal to 3. And then don't forget, it's very easy to check your answers here. If x equals 3, then let's go ahead and take 5 to the x plus 6, which would really be 5 raised to the 9th. Gives us that large number, and let's take 125 and raise to the x. In this case, remember x was 3. And we got the same number, so that tells us that we got the right answer. Now notice it makes 7b a little bit different than a. With a, it was possible to write one of the bases to have the same base as the other one. We can't really do that with 159 very easily. We can't write it as 4 raised to some power. So these are the problems where we have to do log, plug, and then divide. So let's take the log of both sides. The plug property tells us that we can take that 3x and move that out in front. So now we have 3x times the log of 4 equal to the log of 159. And now here comes our divide move to get this x here, this 3x by itself. Now we can divide by the log of 4. So now 3x is going to be equal to whatever the log of 159 divided by the log of 4 is. Oh, it's 159, right? Close your parenthesis. So about 3.656. Notice here we're still not done. We didn't actually find our solution yet. The last thing we have to do now is to solve for x by dividing both these values by 3. And that'll tell us what x is here. So let's go back and let's divide that previous answer here by 3. So 1.219. There we go. Alright, so now to solving the logarithmic equations. What makes 8a so epically awesome here is the fact that we have two logarithms on both sides of the equal sign and both have the same base. So if they both have the same base, then what that implies is that 2x minus 7 has to be the same as 6x plus 5. So then we just set those equal to each other. 2x minus 7 equals 6x plus 5. Let's get x by itself. I'm going to subtract 2x and make this a 4x. Let's subtract the 5, subtract from the negative 7 to make it negative 12. And then let's divide by 4, so then x would be equal to a negative 3. Now pause here for a second. Remember with logarithms you can't take the log of a negative number, but notice in this case it's going to be alright in both cases, right? I don't know. If we take that negative 3, plug it right in there, doesn't that give us negative 6? And then negative 6 minus 7, rut-row, does not work. So what does this tell us? I don't think there's a solution to this problem because the only one that we had didn't work. So how do we like that? Yeah, no solution. How about B? A little bit different. Do you notice what's different about the two logarithms? Now they're on the same side of the equal sign. So what we need to do is use one of our logarithm properties. Let's write this as a single logarithm. Because of the plus sign there, we have to multiply these together. So we'll have a log base 4, 8x times 2, I believe that's 16x, right? So what move do we make now that we have a single logarithm? We have 1, 2, 3 things here. Let's rewrite that as an exponential. So 4 to the 4th power is going to be equal to 16x. Shoot, what is 4 to the 4th power? I know 4 to the 3rd is 64. 64 times another 4. Pretty sure that's 256. So if 256 equals 16x, then solve, we have to divide. I know my enough perfect squares to know that if I divide by 256 by 16, I'm going to get 16 again. Now is this one going to be okay? I think so, because we plug a 16 in there, we're going to get a positive value for that logarithm. Number 9, determine whether this thing is exponential or not. Not too bad of a job here. All we have to do to figure out if something is exponential just means it has a constant ratio. In other words, the name of the game here is multiply. So if we're multiplying by the same number each time to go from one term to the next, then that's a dead giveaway that we're dealing with an exponential function. So if we take the 2.5 divided by the 0.83 repeating, I talked a little bit about this in class, the trick to dividing it by 0.83 repeating, if you don't know what the fraction for that is, just take your 2.5 and then let's divide it by 0.83 and then just do enough 3's to get your point across. That ought to do it. Just notice there we get 3. Alright, great. So if we were multiplying by 3 here, 2.5 to 7.5, I'm pretty sure we multiplied that by 3. 7.5 to 22.5, let's go ahead and divide those. Remember, in order for us to say that this is exponential, every single one of those ratios needs to be the same number. So we get 3 there. That's good news. And then our final check here, 67.5 and 22.5. Notice I'm taking the second number and dividing it by the previous one. That's going to be very, very important to do. So in each case there we get 3. So since we're multiplying by 3 each time, is this exponential? Yes. And if so, what's the constant ratio? The constant ratio here is 3. Okay? If we did not get the same number here, then our answer obviously would be no. And we wouldn't have to list a constant ratio. Okay, so let's look at number 10. I noticed thanks to some of my more astute students in class that noticed this little Easter egg in this little review that we had here. Yeah, whoops, sorry about that. That's the byproduct of copying and pasting problems over and over again over these years when you look at this problem. Sometimes you don't really proofread it afterwards. But anywho, if we look at this problem here, Steve invests $3,000 in account, 2.5% interest compounded continuously. When you're doing a continuously compounded interest problem, you have to use this formula here, the PERT formula, when you use that irrational number as E. Remember, P stands for your initial amount invested. So if we're trying to figure out how much money is in there after 10 years, take the initial amount invested, 3 G's, multiply it by E, and then raise it to your rate. Careful, the rate needs to be a decimal. So we're going to, some of you might be saying, it's already a decimal. No, it's a percent. We have to change the percent to a decimal by moving the decimal point 2 places over. So 0.012, so we need a 0 and then 25. And then we're going to multiply that, because it's R times T, times the number of years, so 10 years. So please try not to overthink this thing here. It's just a basic plug and chug problem. 3,000 E raised to the 0.025 times 10. Alright, so there you see it there, 3,000 times E raised to the 0.025 times 10. There's your value right there. Try not to overthink this. And when you're writing this value out, remember, we're dealing with money, right? So we better round this here. So our answer should be something like this, right? $3,852.08. Okay, number 11 deals with transformations. I want you guys to be able to take a function of any kind and perform a few transformations on that function, and write what the new function would look like. So just to remind ourselves of those tables that we had from our notes from the other lesson, there they are. So according to this one, we need to take this function 3 to the x, do a vertical compression of 1/2. So when we do a vertical compression of something of 1/2, that a value needs to be right before the function. You can kind of see one right there on that function. So our new function is going to start off just like that, with 1/2 going in front of it. Now, do we need to modify the power here? I don't think so. So if we're looking at this here, and by the way, I don't like the parentheses there. I'm going to put the parentheses around the 3. Now the question is do I need to change this x here? Notice it says a vertical translation of 5 units up. So vertical translation here, no. I'm going to put that value after the exponent. Don't put it up here in the exponent here for vertical. So we want to write this as x being right out here, and then if we want to move it 5 units up, there we go. There's our function right there.